Welcome back, everyone. So we've talked about the Planck era, and we've talked about the inflationary epoch, and now we want to talk, we're still very much in the early history of the universe, before a second, essentially, has elapsed. But important things are happening, and in particular, we want to talk about the idea of phase transitions occurring in the early universe. So what is a phase transition? We all have experience of this, is when we take liquid water, right, which, you can take water and you can pour it into a cup, and you can pour it into another cup, and it takes whatever, shape the container has. But then you put it into your freezer and you go away for a while, and you come back, and now suddenly you've got a chunk of ice. So the water has gone from a phase transition from being a liquid state to the solid state. And of course, if I took that solid state and put it in a boiler, then what would happen is the solid would turn back into a liquid. So the movement from one phase to another is what is called a phase transition, and it's clearly associated with temperature. So the universe actually is doing the same thing, because we have to understand that the temperature in the universe is dropping with time. As the universe expands, its temperature is dropping. And we're going to get phase transitions like, the analogy of going from a liquid to a solid. Things are going to change as that temperature drops. So one of the first things that's going to happen is, what we believe is that early in the universe, the four forces of the universe were actually one. There was one grand unified force, only one force operating. And as the universe cooled, that force broke out at various times, into the four forces that we see today. And it didn't all happen at once. And the one thing that we know about is that the electromagnetic force and the weak force, if your temperature is high enough, those will merge into one. So there must have been a time when all four forces were together, and then the strong force and the electro-weak force must have separated out. Actually, of course, gravity must have separated out. But we don't understand that at all, but we do certainly understand, we've already in our particle accelerators come to understand the electro-weak force, and how the electro-weak force splits out into the electromagnetic and weak force. And so at around, when the universe was about 10 to the minus 12 seconds and had a temperature of 10 to the 15 degrees K, then the electromagnetic and weak forces were still together, but as you're passing through this transition, it'll eventually split apart it'll freeze out, it'll make a phase transition into the electromagnetic and the weak force. So, but at this time, essentially, they are still merged together. So another important phase transition comes about and is associated with quarks. So I've already mentioned this before, but it's important to understand that quarks, at the energies that we have today in the universe, you never see free quarks. Quarks never occur alone, essentially. All the quarks that we see in the universe today are all bound together in what are called hadrons, so things like protons and neutrons. And in fact, if you try and pull two quarks away from each other, the force actually increases the farther they get away from each other. So it's impossible to pull them apart, the energies that we see today. But early on in the universe, the energies were so high that it must be that quarks could have just run around and do whatever they wanted. They were free to move around. But of course, as the temperature of the universe decreased, there must have come a time when now the energy of motion in the quarks was lower than the binding energy, the energy that the quarks want to have to pull together and form hadrons. So there must have been a free quark, bound quark transition. And so this is what is called the quark-gluon phase transition. And at a time around 10 to the minus 6th of a second, which is a millionth of a second, and when the universe was 10 to the minus 12th of its current size, and the temperature was 10 to the 12th degrees, that was when essentially quarks were bound together to form hadrons, things like protons and neutrons that we see today. And after that, they could never be separated. So that is also a very important phase transition. The universe went from having quarks running all over the place to suddenly quarks only appearing in things like protons and neutrons. Okay, so these phase transitions are very important to understand the history of the universe, because even though it happened very early, it left the stuff that was frozen out, as we might say, is what we see today. Okay?